Group 6, and we're doing the produce impurity detection system with
Jared Beach.
Kevin Saylor.
and Angelina Picone.
Okay, so the little introduction to this project. The idea behind this is just to bring agriculture into the present with AI. Some of the things we wanted to increase was safety, accuracy, speed, and consistency. We just want to update what's currently available in the market. Some of the design factors are performance, functionality, economics, energy. Take all these into consideration. We also have to take into consideration your code of ethics, health and safety, stuff like that. Okay, so we had three main redesigns of our project. We used the eco design wheel, disruptive technology, and failure mode effect analysis. Each one came out to some different redesigns. Failure mode effect analysis came up with us needing multiple components like cameras and stuff like that, just so if stuff fails or breaks, there's backups. Disruptive technology was more, it came to, hey, we need to lower our costs so that we can be disruptive in the market. And then eco design wheel is, we looked at, hey, we need to be eco-friendly, so let's recycle our materials. So the evaluation of these three redesigns, we took cost, accuracy, and speed into effect because that's what we found most important. As you can see, option one, using the failure effect mode analysis, it beat out disruptive and eco design.
So after going through all that evaluation, we then decided to look into price of a prototype. So some of the things that we identified were key parts of our prototype was the conveyor belt, the cameras, the bins, the flipper mechanism, and of course the engineers that are building all this. So conveyor belts, we looked on Amazon, and for each of the other items, we also looked on Amazon as they didn't incorporate shipping or any other bonus charges that would increase the cost of the overall price that we saw. So for the conveyor belt, we saw it was between $375 to $1,200, varied on size of the conveyor belt and other items such as handlebars or other mechanisms that might be included in the conveyor belt. Cameras, for $45.99 was the cost of 2 webcams. If we would want nicer cameras, then that price would obviously go up. Bins, $100, and the flipping mechanism we estimate to be $750 due to the engineering costs and other prices that might increase the cost of the flipping mechanism, but none of us are mechanical engineers, so we did not know what the actual price of that mechanism would be. And then, of course, engineers, if it's a capstone, it would be free. If it's, of course, you pay actual engineers, you would have to look into salaries for each of those for the designated months that we'd be doing this.
So for the work breakdown, we figured 4 individual important parts, the first being the creation of the AI algorithm itself, the second being the mechanical portions, the third being the setup of the safety protocols, and the fourth being testing. Further breakdowns can be seen here with each of their deliverables. This is part 1 of the AI, this is part 2, the mechanical portion, part 3 being the safety setup, and part 4 being the testing. Speaking of testing.
Yes, so we then, after going through the entire engineering calendar, designed a test plan. The first, of course, being the mechanism testing. That would include your cameras, the flipping mechanism, the conveyor belt, all working in conjunction and doing their job properly. The second being the safety test that would encourage that all the safety precautions and safety utilization that we put into the machine all work properly, such as the alarm system. And lastly, user testing, which would ensure that users would be able to use the device correctly, safely, and functionally so that each of their utilities would be able to be used properly. So the first one, of course, is the mechanism testing. This would encourage that we are looking at efficiency, accuracy, and consistency. Each of these are very priority because you don't want to be dumping bad fruit into the wrong bin. The way we wanted to do this was that we would give a very, very specified group of fruit to the machine and ensure that the quality of the fruit that was being pitched was correct and that each of the problematic fruits were identified correctly and pitched correctly. This would encourage that we saw the machine working efficiently, and of course the accuracy of the test would be able to be measured properly. We also want to do this multiple times to encourage that the consistency of the machine is properly done and that we're not just getting one test result out of this machine.
Next is the safety test plan. So the features to be tested are the alarm system and the conveyor belt mostly. The deliverables will be a safety plan that could be used in the future and any documentation of the testing for a backlog. And then the setup of the test would include identifying any safety concerns and then testing to make sure that the system works accordingly and adjusting based on that, and creating the safety plan for workers based on the data gathered. The pass-fail criteria is checking to make sure that they're fully thought out contingencies and that they're OSHA compliant.
Okay, so the last is the user test plan. This is a test just to ensure that our device is user friendly. So we're going to test the entire system with user integration. Some of the deliverables would be like a user manual and like the documentation of the tests. The approach is we're going to oversee the usage of the machine, and basically see how long a user takes to learn the machine and if they do it properly or not. Our pass-fail criteria is going to be the learnability and the proper use percentage, basically how often are they using it properly.
Thank you. If you have any questions, let us know.